The James Webb Space Telescope, JWST, is a space telescope currently conducting infrared astronomy. As the largest optical telescope in space, it is equipped with high-resolution and high-sensitivity instruments, allowing it to view objects too old, distant, or faint for the Hubble Space Telescope. This enables investigations across many fields of astronomy and cosmology, such as observation of the first stars, the formation of the first galaxies, and detailed atmospheric characterization of potentially habitable exoplanets. The U.S. National Aeronautics and Space Administration, NASA, led JWST's design and development and partnered with two main agencies, the European Space Agency, ESA, and the Canadian Space Agency, CSA. The NASA Goddard Space Flight Center, GSFC, in Maryland managed telescope development, while the Space Telescope Science Institute in Baltimore on the Homewood campus of Johns Hopkins University currently operates JWST. The primary contractor for the project was Northrop Grumman. The telescope is named after James E. Webb, who was the administrator of NASA from 1961 to 1968 during the Mercury, Gemini, and Apollo programs. The James Webb Space Telescope was launched on December 25, 2021 on an Ariane 5 rocket from Kourou, French Guiana, and arrived at the Sun-Earth L2 Lagrange point in January 2022. The first JWST image was released to the public via a press conference on July 11, 2022. Initial designs for the telescope, then named the Next Generation Space Telescope, began in 1996. Two concept studies were commissioned in 1999 for a potential launch in 2007 and a $1 billion budget. The program was plagued with enormous cost overruns and delays. A major redesign in 2005 led to the current approach, with construction completed in 2016 at a total cost of $10 billion. The high-stakes nature of the launch and the telescope's complexity were remarked upon by the media, scientists, and engineers. The design emphasizes the near to mid-infrared for several reasons. High redshift, very early and distant, objects have their visible emissions shifted into the infrared, and therefore their light can be observed today only via infrared astronomy wink with a frown 13. Infrared light passes more easily through dust clouds than visible light wink with a frown 13. Colder objects such as debris disks and planets emit most strongly in the infrared. These infrared bands are difficult to study from the ground or by existing space telescopes such as Hubble. Ground-based telescopes must look through Earth's atmosphere, which is opaque in many infrared bands, see figure at right. Even where the atmosphere is transparent, many of the target chemical compounds, such as water, carbon dioxide, and methane, also exist in the Earth's atmosphere, vastly complicating analysis. Location and orbit. JWST operates in a halo orbit, circling around a point in space known as the Sun-Earth L2 Lagrange point, approximately 1,500,000 kilometers, 930,000 miles, beyond Earth's orbit around the Sun. Its actual position varies between about 250,000 and 832,000 kilometers, 155,000 to 517,000 miles, from L2 as it orbits, keeping it out of both Earth and Moon shadow. By way of comparison, Hubble orbits 550 kilometers, 340 approx. Above Earth's surface, and the Moon is roughly 400,000 kilometers, 250,000 miles, from Earth. Sunshield protection. To make observations in the infrared spectrum, JWST must be kept under 50 K, minus 223.2 degrees Celsius, minus 369.7 degrees Fahrenheit, otherwise, infrared radiation from the telescope itself would overwhelm its instruments. Its large sunshield blocks light and heat from the Sun, Earth, and Moon, and its position near the Sun-Earth L2 keeps all three bodies on the same side of the spacecraft at all times. The 5-layer sunshield, each layer as thin as a human hair, is made of Captain E film, coated with aluminum on both sides and a layer of doped silicon on the sun-facing side of the two hottest layers to reflect the sun's heat back into space. Accidental tears of the delicate film structure during deployment testing in 2018 led to further delays to the telescope. Here, we share informative content that we hope you'll enjoy. Our channel covers a wide range of topics to learn and increase your knowledge. If you find our videos helpful to learn or informative, please consider subscribing to our channel to stay up to date with our latest content. We love to hear your thoughts, so feel free to leave a comment below and let us know what you think. Don't forget to share our videos with your friends and family. We appreciate your support and look forward to bringing you more great content in the future.